Hello again, everyone. Mr. Cruze here with another trigonometry review for you. This time the 3.3 and 3.4 quiz review, which is over all the different properties and identities involving sine, cosine, and tangent, as far as multiple argument property, double angle, things like that. All right, let's dive right in. Some of these will take a little while. There will probably, in all likelihood, be a second video. See the link in the description for the second video. All right. Number 1 and 2 say evaluate without a calculator. Exact answers. That means if you give me decimals, it will be wrong. All right. You should probably have some sort of radical or fraction or something like that. Exact answers. So cosine of 105 degrees. Now, whenever they say exact answers, I'm probably going to go to that special table that I gave you guys the other day, right? And I notice 105 is not on there. All right. However, if there was some pair of angles maybe that added or subtracted to 105, I could use that instead. And it turns out there are. Cosine of 105 is also the same thing as cosine of 45 plus 60 degrees, right? 45 and 60 is 105, of course. And I know what to do with that. If I have cosine of A plus B, there's a formula for that, right? And it starts off cosine of A, which in this case would be 45 degrees, cosine B, and it's always the opposite sign, so it was plus, so now it's minus, right? Minus sine of A, which would be 45 degrees, sine of B, sine of 60 degrees. All right. Hopefully you're good so far. Now I'm going to start plugging some things in. Cosine of 45 is rad 2 over 2. Cosine of 60 is 1/2, and again you can use your chart for this. Sine of 45 is rad 2 over 2 as well, and sine of 60 is rad 3 over 2. Now you're multiplying, so we're just going to simplify. Rad 2 times 1 is rad 2 over 4. Nothing simplifying there. Minus rad 2 times rad 3 is rad 6 over 4 again. Since they both have the same denominator, I'm going to go ahead and put them over the same denominator. Please be careful. There is nothing you can do with rad 2 minus rad 6. No combining. All right. Just leave them like that. Nothing's going to reduce, and we don't have any radicals in the denominator, so this one's actually quite nice. Cosine of 105 is rad 2 minus rad 6 all over 4. A couple of you have figured this out. Check your answer. Type cosine of 105 in your calculator. You'll get a decimal. Type rad 2 minus rad 6 over 4 in your calculator. You should get the same decimal. If you don't, then you've probably done something wrong. Okay? Sine of 75, let's do the same thing. Let's see if we can maybe combine a couple angles to get that. And we can if you take sine of 30 plus 45. Now, there's a formula for sine of A plus B, right? So you can do sine of 30 cosine 45. Sine is always the same sign, so we're good there. Plus cosine of 30 sine of 45. Now start plugging things in. Sine of 30 is 1/2. Cosine of 45 is radical 2 over 2. Cosine of 30 is rad 3 over 2. And sine of 45 is rad 2 over 2. Kind of looks like we're going to get a similar answer here, right? 1/2 times rad 2 over 2 is rad 2 over 4. Plus rad 6 over 4. Hey, look. They're very close to the same answer. Not quite the same. Now it's a plus sign between, right? And again, feel free to check your answers and make sure that it works. All right, let's try number 3. If sine of A is 2/5 and the cosine of A is greater than 0, cosine of B is negative 12/13, and tangent B is less than 0, evaluate cosine of A plus B. So again, we know cosine of A plus B is cosine A cosine B minus sine A sine B, right? We need to know this information. We already have sine A and cosine B, right? We've got cosine B, we've got sine A. We need to figure out the other two things. So let's actually figure these things out. Let's do A first. A is some angle, right? Or it could be an arc. Sine is positive 2/5. Sine is positive in quadrants 1 and 2. Sine is positive in quadrants 1 and 2. Whereas cosine, it's greater than 0, so that means it's positive. Cosine's only positive in quadrants 1 and 4. Well, where do the two overlap? Quadrant 1. So we know we are in quadrant 1 here. Whatever A is, whatever angle it is in quadrant 1. So A is in Q1. So let's draw some triangle. Again, doesn't have to be perfect. We're just sketching it. Sine is opposite over hypotenuse. So if A is here, opposite would be 2, hypotenuse would be 5. A little Pythagorean theorem, 25 minus 4, this would give you radical 21. Everything's nice and positive. Okay, let's do the same thing for b. So the cosine is negative. Well, cosine is negative in quadrants 2 and 3, and the tangent of b is less than 0. So that means tangent's negative. Well, tangent's only negative in quadrants 2 and 4. So where do they overlap? Quadrant 2. So we are in quadrant 2. B is in Q2. Alright, so let's draw our triangle. We know cosine is adjacent, so negative 12 over 13. Remember, the radius is always the positive one. A quick little Pythagorean theorem will tell you that that has to be 5, right? So now we can actually figure this stuff out. Cosine of A. Well, cosine is adjacent over hypotenuse, which in this case would be radical 21 over 5. That's the cosine of A. Cosine of B, we already know, is negative 12 over 13, but you can use the picture too as well, adjacent over hypotenuse. Minus sine of A, well, we already know sine of A is 2/5. Again, you can check your picture. Sine of A is opposite over adjacent. And sine B is 5 over 13. Do a little multiplication. Negative 12 radical 21 over 65 minus 10 over 65. So we end up with negative 12 radical 21 minus 10 over 65. The only thing you need to check, do these three numbers have anything that we can divide all three of them by? And the answer is no. 65 and 10 share 5, but they don't share it with 12. 12 and 10 share 2, right? But nothing really reduces there, so you end up with that. Notice, did we actually figure out what A and B were? No, we didn't need to. All we needed to know were what were some of these values, right? What were cosine of A, cosine B, sine A, sine B? We just had to figure out each of those individually. All right, now we get to the verify the following, all the different identities. These are the ones you guys have the most fun with, right? All it is a little bit of tricky algebra to rewrite one side into the other. You're not really doing anything with both sides. You're just picking one side and trying to change it to the other side. All right? Pick the most complicated side. So let's do number 4. I'm going to say start from the left. It looks more complicated. This, to me, I hope it does to you, looks like cosine of A minus B. All right? So let's try that. Cosine of A minus B, if I remember correctly, is cosine A cosine B plus sine A sine B. All right? So let's plug that in. Only this time A is theta, B is pi. So we have cosine theta cosine pi minus sine theta sine pi. But here's the weird thing that these types of identities have. Cosine pi and sine pi we actually have values for, right? Cosine theta, we don't know what that is, but cosine of pi, we certainly know that that's negative 1. And again, sine theta we don't know, but sine pi we do. Sine of pi is 0. Well, what happens? Negative 1 times cosine is negative cosine. Minus 0 times sine is 0. We end up with just negative cosine. Look at that. That's what we were trying to get to. Okay, so a lot of it is, can you look at a problem and be able to relate it to something that you know how to do, right? And figure it out from there. Again, take a look at number 5. Cotangent theta equals 1 plus cosine 2 theta over sine 2 theta. Again, pick the more complicated side, so start from the right. I seem to notice that there is a cosine of 2 theta and a sine of 2 theta. We have formulas for those. We have identities for those, right? So let's try those out. Let me do sine of 2 theta first. Sine of 2 theta is 2 sine theta cosine theta, right? That's the double angle formula for sine. Cosine, you'll remember there are actually 3 for cosine. Cosine of 2 theta can equal one of the following things. It can equal cosine squared theta minus sine squared theta. It can equal 2 cosine squared theta minus 1, or it can be 1 minus 2 sine squared theta. The big question is, which one do we want to use? Well, let's think about where we're headed. We're headed towards cotangent. And remember that cotangent is cosine over sine. I already see a sine in the denominator. I need something in terms of cosine only in the numerator, right? So I'm going to pick option 2 here. 2 cosine squared theta minus 1. Okay? Now, let's see what happens. Well, this 1 and this negative 1 add to 0. And I'm left with 2 cosine squared theta over 2 sine theta cosine theta. And let's see what magic happens here. The 2's divide to 1, so they go away. I have a cosine in the denominator, and I have a cosine squared up top. So, I end up left with exactly where I wanted, cosine over sine, which is cotangent, which is exactly what we wanted. Okay, so again, a part of it is use the formulas, but figure out where you're headed. If I had picked one of the other options, it might have been a little different. All right. Number 6. 1 plus cotangent x over cosecant x equals 1 plus tangent x over secant. You'll notice both sides are pretty much the same, so how do we know which one to start with? Well, take your pick. I don't really mind. Personally, I'm going to do the left side, because I'm a left to right kind of person. So let's see, 1 plus cotangent x over cosecant x. I'm trying to get to 1 plus tangent x, right? So here's what I'm going to do. I'm going to take my 1 plus cotangent x. I'm going to multiply the top and the bottom by tangent x. You might be thinking, why would you do that, Mr. Cruze? Well, if I do that and I distribute, tangent x times 1 is tangent x. And you'll remember tangent times cotangent equals 1 as well, right? Tangent x plus 1. Hey, look, that's what we want on the top. And on the bottom, tangent times cosecant. We'll deal with that here in a second. I'm going to go ahead and rearrange the top because we want it to be 1 plus tangent x. On the bottom, tangent in terms of cosecant is secant x over cosecant x. And when I multiply that by cosecant, look what happens to the cosecants. And I'm left with 1 plus tangent x over secant. Again, there's multiple ways to do these same problems, okay, but these are just some quick ways. All right, number 7. 2 sine x cosine x over 1 plus cosine squared x minus sine squared x equals tangent x. Now, I see the tangent x and I know, that's sine over cosine, right? If somehow I can get everything over here on the left side to become sine over cosine, then we win. We'll have tangent, right? I already see some sines and cosines going on, right? So let's use that to our advantage. 2 sine x cosine x over, I see this part right here, cosine squared minus sine squared. And I know that equals cosine 2x. And I also, by the way, notice the top is sine of 2x, right? But obviously, I don't want things in terms of 2x. I want things just in terms of x. So I need to think of a different way to rewrite this. Again, I'm trying to get sine over cosine, right? So I want my entire denominator to be in terms of sine. And there is. One of our cosine of 2x formulas is in terms just strictly of cosine. It's 2 cosine squared x minus 1, right? Well, look what happens. The 1 and the negative 1 add to 0, so they go away. And I'm left with 2 sine x cosine x over 2 cosine squared. And some fabulous canceling magic happens. The 2 divided by 2 go away. One of the cosines goes away on the top and the bottom. And I'm left with sine x over cosine x, which is tangent x. And we win, folks. Alright, I'm going to stop the video here. We'll do the remainder of the review in the next video, alright? Again, if you have questions, tweet me, email me, come in early in the morning. I want you to do well on this quiz, and I hope you want it as well, alright? See you all next time.